The example that we saw just now is one of a large class of problems where we have got two inputs and one output. and both the inputs are categorical in nature, so they are variety and tilt. In this case, both were categorical. Variety had 3 levels and tilt had 2 levels for us, slope or plane, one continuous output, one random input. As I have already mentioned earlier, these things are sometimes called two-way ANOVA model, but a more natural terminology would be just to call it two-factor model. So I think I prefer this two-factor model terminology instead of the traditional two-way ANOVA model, which sounds weird. What is two-way ANOVA here? Just call it the two-factor model. Now there are lots of different types of two-factor models that are possible. We have seen only one of them. Now the general format of this two-factor model is this. You have got factor 1 and factor 2 and you have got the response. Now let us look at a few other examples which is somewhat different from the example that we have seen, yet they also come under the same umbrella of being a two-factor model. Here is another one which is something that we have already used in our class. Again variety, but now instead of using tilt, I am using fertilizer and the output is still yield. What's the main difference? The main difference is in case of that variety tilt case, we had one treatment variety and one control factor. But in this case, both the things are treatments because we have consciously applied the variety. We have consciously applied the fertilizer. So both of these are treatments. So in this case, when you carry out a similar random allocation, the strategy will be different. Suppose we start again with 24 such plots as identical as possible, etc. Now there is no question of tilt. Now you have got how many combinations? 3 varieties and say 2 fertilizers, just to make it compatible with that fertilizer tilt example. So I'll again make 3 and 2. So there are 6 possible combinations. You have 24 plots. So randomly split all those 24 plots into 6 groups of 4 each. And then apply the corresponding pair to each one of them. So variety 1, fertilizer 1, variety 1, fertilizer 1 goes to 4 plots, randomly selected plot. Variety 1, fertilizer 2 goes to the next 4 randomly selected plots, and so on. So the way we randomize that is now different because fertilizers are under our control. Now here is yet another example, this time from a clinical study. So here I have a patient as my basic system, and I have a drug, and I have the gender. This is again of the type where the gender thing, that is a control factor. So again, when you carry out this experiment, you have to, just to be compatible with the last case, suppose we are still working with 24 patients as opposed to 24 plots, you need 12 of them males, 12 of them females. So typically you will select your 12 males from a larger population of male patients and 12 females from a larger population of female patients, and they should be as identical with respect to the other things like their age group should be more or less the same, their medical history should more or less be the same. And then out of the 12 males, you will apply your drugs more or less equally spaced. Suppose you have 3 drugs, 3 comparable drugs, or maybe 3 different doses of the same drug, and then you will do that. And similarly over the females. So you will randomize over males, independently randomize over females, and your final output will be some kind of a diagnostic measurement like blood pressure measurement, amount of sleep, or something. Okay. So these are the different types of examples. Now here is yet another one. So this is taken from a social study where a student is your basic system, and you want to see how effective is the medium and the location. Suppose medium happens to be 2 mediums, a vernacular and English. And the location could be rural or urban. So there are 2 here, 2 here. In this case, there is no treatment because The person who is carrying on conducting the study is not applying the medium to anyone. So it is not that you pick certain random kids and then you put those kids into a certain school or send them to villages or send them to cities. You are not doing that. So when you are picking students, they are already studying in a school, they have a medium, they have their locations. You are merely passively observing them. So this is an observational study. But this again comes under the same setup of a two-factor model. So in this case, how do you carry out the randomization? So you have to pick students in a way such that you have, so suppose there are two media and two locations, so 4 possibilities. So pick some, say for example, pick 10 students from each of these possible combinations randomly and then look at their marks in some board exam. So you see, the way you randomize, that changes from the setup. But at the end of the day, you get something which is of two-factor, and the modeling and the mathematics, etc., that remains the same. But how you carry out this randomization, how you collect the data, that will change from one setup to another setup and always follows the most common sense procedure. Nothing very profound going on here.